Bruh. Hello everyone. Welcome to Monday's stream. Hope you had a good Friday. Well, a good weekend. Ah. This week is going to be a short one here in the UK because we have the Platinum Jubilee. You know, the fancy thing that the UK has, the monarchy, right? So there is an additional bank holiday this week, which means that I don't know. I will likely not stream on Wednesday, but I will probably stream on Friday at this point. There are a couple of things that will happen this week, so I will not have enough time to. Well, I'll probably not be able to stream. Pretty much, I think. But yeah, hopefully it's going to be another good one today. On Friday, I did the, I guess at this point, the first deep dive into GObject, which means taking the core of the GNOME platform, the GObject type system, and try to explain how it works and how it's put together and how you can use it to write your own code, but mostly to understand why things are the way they are and how all the magic macros and all the API work in a way that it's understandable if you are trying to use it without literally copy and pasting things together. Hi, Scarrow. Yeah. Yeah, today is going to be another hopefully not a long stream. I'll try to add a break in the middle so that people don't get overwhelmed by a lot of information and they don't have their brain just bleed through their ears. So I did this kind of tutorial a decade ago. It wasn't a tutorial on GObject, it was a tutorial on Clutter, the toolkit that I maintained while I was working at OpenEnd first at Intel after. And that is the basis of the GNOME shell. I had to do a couple of tutorials / deep dives into how Clutter works and how it's put together and how to use it to write your own UIs. And of course, when you start explaining how a toolkit based on GObject works, you also have to start explaining how GObject works, because not everyone is familiar with it. And at the time, GObject was a little bit more rough. A lot of the macros that these days we take for granted did not exist, or if they did exist, they were very new. You were supposed to write your own get type function, for instance, most of the time. And it was funny trying to explain how the type system worked, and then try to explain how an entire toolkit based on GL worked. I did have the chance to explain how Clutter worked in a 4-hour session with Linus in attendance once. And he actually asked a couple of questions as well. So that was fun. But I've never done a complete, like, I'm gonna say a complete tutorial, but it's not really a tutorial. It's like a complete deep dive into GObject, because most of the time, whenever I presented any kind of API based on top of GObject, I was talking to people that were at the very minimum familiar with the concept. Mainly because they were used to GTK, for instance, or because they were already kind of getting to know the platform. So I was just going through the upper layers of the stack, so to speak. So this is kind of the first time. Hi, Nifty. But yeah, the overall idea of this deep dive is mostly to try and familiarize more people with the concepts, less trying to explain why things don't change or the nitty-gritty of the actual implementation. If you want to see the actual implementation, it's pretty self-contained. You have to open up the glib source code and then go into gtype.c, and you will see how it's implemented. It's not super complicated. It doesn't require like god tier level of C like wizardry. It's not very complicated. It requires some understanding of locking, mostly because the entire thing has to be thread safe, but other than that, it's pretty much just store a bunch of data structures and then try to walk them as efficiently as possible, and then allocate a bunch of memory and call a bunch of function pointers. It's not it almost like I'm downplaying it, which I'm really not. I'm really not downplaying it at all. It's not complicated. The design of it, it's probably the most complicated part. The ideas behind it, because they are a collection of a bunch of things that happened over the years on top of an existing design. And mainly the only reason why things cannot change is because changing them, I'm not going to say inevitably, but very likely break some existing code base. Yeah, for instance, like we talked about properties last time. So you would think that because most of the code that exists today installs properties once and only inside the class instance, class initialization function. So you have class in it, and then you set up all the properties with gparams_spec, and then you call GObject class install properties. And you would think, okay, that's where you install properties, right? And that is correct now. But at the very beginning, you could literally install properties on any GObject class at any random time. It wasn't necessarily done inside the class initialization. it would be very, very wrong to allow that. Well, to do that. No project was would do that, right? And in point of fact, yes, like 99.9% of the projects did not do that. Did not try to install properties after the class was initialized. Except, and as it turns out, when we're trying to enforce that rule, like 10 years after GObject was released, turns out that there were two projects that were doing that. Were the C++ bindings and the C# bindings, because they would instantiate the type and then they would retrieve the class and install properties after the class had been initialized. So they had to change the language bindings to avoid that. But between the change that enforced the rule that you cannot install a property after the class has been initialized and the actual enforcement, we had at least, I think, a year where basically we had to add an escape hatch inside GObject to say, oh, this looks like a type that was registered by the C# or the C++ bindings, so let's not warn right now. And after the C++ and C# bindings were fixed, we removed that escape hatch. But it's really hard to change any behavior on GObject and the type system, because a lot of code exists out there that has been written a long time ago and maybe takes advantage of something that is undocumented, some undefined behavior. And you don't want to break that like outright, but you still have to take that into account whenever you change things. To be fair, in the past decade, I think we've become, no, less than a decade now, we've become a little bit less beholden to that rule. We started saying, okay, if it's undocumented and it's complete like gray area and you're doing this because it's, I don't know, more efficient for you, or it's just something that you didn't consider, like doing the right thing was not something you considered, then we basically say, okay, you have like 6 months to fix your code, and we're going to do it anyway at that point. If you don't fix your code, it's your fault. That's what major releases are made for. Yeah, that's the problem, right? If we could have released like GObject 3 at this point, like 15 years ago, but it was already too late. Once you start getting users in your code, users of your API, it gets really hard to enforce that. That's also the reason why GTK, so we had GTK 1 released in 1997, and then we had GTK 2 released in, what's that, 2001? So it was less than 4 years. But then between GTK 2 and GTK 3, we had 9 years nearly. And then between GTK 3 and GTK 4, we also had 9 years. The more code exists out in the wild that depends on your API, the less inclined you are to do an API break, unless it's scheduled and unless it's well known in advance. So I mean, it's a lot easier to break API because you have to fix stuff if you're maintaining a cargo crate that is downloaded like 100 times per week or 1,000 times per month. It's a lot harder to justify that when you are the core of an entire operating system. So you have the other option, if you have resources enough, to basically just add a bunch of exceptions inside your code and do what Microsoft does for their own API. So you basically just do pattern matching on who's calling your API, and then you add a bunch of escape hatches. But that requires a lot more resources than GNOME has ever had in its entire history. So for that, we kind of settled into this pattern of, okay, we are going to break API in, I don't know, 5 to 10 years. Please help us identify issues with the API while the API is still in flux, which never happens. People will wait until the release is done, and then they will complain about the API. But yeah, it's the main problem of maintaining an entire software development platform with just a bunch of volunteers. That's it. That's the main issue. And again, it's an entire software development platform. It's not just a single library. And the closer you are to the bottom of that platform, so GDib, GObject, then the harder it becomes to break, even after like 20 years. We did talk a while ago, I think like 3-4 Guadecs ago, about like starting the process of figuring out GObject 3 or GObject 4 or whatever it is at this point, and basically a replacement for GObject. And the main problem is that, okay, you modify GObject, let's bump it to 3, and then we have to bump GStreamer, which is a massive project, and then we have to bump everything that GStreamer provides, which is a lot of modules, and a lot of them are loaded at runtime, so they cannot distinguish between GObject 2 and GObject 3. Then you have GTK 4, GTK 3, well, GTK 4 at this point, or GTK 5, and then you have the entirety of the GNOME platform. And it snowballs there. Basically, we barely can do this right now with the amount of maintainers that we have. Adding an entire major API bump across the board is going to be madness. In an ideal world, without those compatibility constraints, what would GObject 3 be? I have no idea. I honestly have no idea. Probably something more lightweight in terms of type system. Right now we are storing a lot of stuff that is there because of some design choices that I don't entirely agree with it. And the what else? Properties should be fixed and should be part of GObject, or should be part of a type system. So down to the G-type instance. Signals should either be part of GObject or part of the type instance as well, but you should like get a notification whenever somebody connects to an object, which is tricky to do because there's a lot of like reentrancy and there's a lot of potential for thread safety issues. Reference counting is a problem right now because it's all implemented using atomic operations. We're going to talk about a bunch of this stuff here, but basically the idea of switching to, I don't know, biased reference counting instead of atomic reference counting. So using non-atomic for any reference counting operation on the current thread, and then switching to atomics for other threads. The ability to store the thread ID that created the object instance inside the GObject, so that you can emit signals well, no, I mean signal, sorry, call virtual functions on the proper thread. Like the mess that are weak references, the mess that are toggle references, the fact that you cannot have multiple garbage collectors that reference the same C object instance without competing between them. There's a lot. The fact that GObject does not know its full size. It only knows the instance size and the private size, but doesn't have the ability to say, this is my full size with all my data inside my instance and private and instance private data. Yeah, I mean, there's a lot of stuff, and some of this stuff is fixable without breaking API, to be honest. It's not strictly necessary to have it to have a completely separate API bump, but the main problem is, how do we verify that we actually didn't break the API? How do we guarantee that existing code will keep working when we have no idea how much existing code actually there is? Because we can fix a bunch of this stuff and then make GTK perfectly happy with it, and then a bunch of applications stop working, a bunch of libraries stop working, and some of those libraries, some of those applications are closed source. And now what? We have no idea. So closed source or internal stuff that it's not visible from the outside, so the licensing terms don't matter at all. But yeah, the main problem is we have no idea how much code we have in the wild, and we have no idea the amount of weird stuff that code in the wild actually does. And if we change something without breaking the API, then we have no idea if we actually broke the API and we introduced subtle changes, or we didn't. On the other hand, if we did bump the major API, then how many people will follow? We can release GObject 3. We can release GObject 3 like next year. It doesn't matter. How many people will follow? It's like, yeah, we can release Perl 6, right? How many people are going to use Perl 6? Those projects can choose to depend on maintaining older version or part. No, that doesn't happen. That never happens. It's really something that very rarely happens. It's like, people are very wary about that. Even if we said, okay, we're going to release like GObject 3 and it's going to be amazing and it's going to have all these new features and stuff, they will not port that code. Oh, the stream froze? Oh yeah, I see the bandwidth bump. Yeah, I'm still having a bunch of issues with my ISP, even though I switched to another network device. Yeah, the upload is still kind of wonky, and download as well. But yeah, this week should be fine. Yeah, another reason why I cannot really I will not be able to stream on Wednesdays because I will probably be waiting for my new ISP to install their router and stuff like that, which means that I will likely not have any internet connection on Wednesday. Yeah, as I was saying, people don't really like when we break API. Even when we say it's gonna be amazing, it's gonna have a whole new set of functionality, it's gonna be great, they will say, okay, we're not gonna switch. We're gonna switch in 5 years. Okay, at that point, we get to maintain 2 libraries now. One that cannot be fixed, and one that can probably still be fixed, but nobody's using. It's the main tension between, like, it's the main problem of any like large free and open source software project, right? So you either decide, okay, I'm gonna break API and people are gonna switch to the new version. Great, if they do. If they don't, which a lot of people won't, then you're basically screwed. Now you have to maintain 2 projects, not 1. So good luck doing that with the same amount of people. Oh. Yeah. So, right. The plan for today. The plan for today is going to be construction and destruction of objects. So when we create an instance, what happens? And when we want to get rid of the instance, what happens? And how do we write the code to handle the first case? And how do we write the code to handle the second case? What happens to properties? What happens to signals? Well, not signals, but what happens to state whenever we create an object? What are the steps that we have to go through? And then for destruction, how do we set the object in destruction? How do we avoid doing unnecessary work? And also what happens to the memory at the end? And we're also going to talk a little bit about construction properties, and we're also going to talk a little bit about the memory allocation policy that GObject currently uses, which is not malloc. It's not the system allocator. Surprise, surprise. At the very least, not for a while. Maybe in the future it will be the system allocator, we don't know yet. So let's switch to my builder instance. And we are going to start with a new file here because the OP basic is there and we don't care about it. So no header file. We are gonna start with a very simple object ourselves. So we start with my type object. And then layer final type. This is a simple type declaration for our my object type. And as I said on Friday, this is how an object is declared. The macro will take care of mostly everything that we care about. The get type function that we mask using macro here, all the type check functions, the structures and type defs for those types. That's it. This usually goes into the header file. So now we go into the source. Let's split this, declaration, and definition. Okay. So, first of all, we need to have our little my object here. So since this is a final type, which means it cannot be derived any further, the the instance data structure is left to us to define. The class data structure is instead declared and defined by this macro here. So let's also, well, now we have to define our type. So we use gdefine final type, and it inherits from gtype object. This one will take care of creating the definition of the myObjectGetType function, which registers the type for us. Now we have to define the class in it. And we have to define the instance in it. This is the usual GObject skeleton. So also on Friday, we saw the constructor function definition, which just calls GObject new. It's important to understand that any C constructor like myObjectNew is just a C convenience API. It's not going to, it's definitely, sorry. Any constructor function that you define at the C level that wraps GObjectNew has to do two things. One, only call GObjectNew. It cannot do anything else there. If you have arguments here, you have to pass them as properties. But also the other important thing is that myObjectNew here, any C level constructor, is going to be a C only API. Language bindings will not call it. When you use GTK Builder, you will not have this function being called at all. Everything calls GObjectNew. So it's important whenever you write GObject code that has to be introspectable and has to be consumable by other languages through GObject introspection, that you don't rely on a C constructor like this, because 99.9% of the cases, everything will go through GObjectNew in any case. Hi, Codex. I honestly have no idea about anything related to Avahi, and I have no idea on mounting and boot. I'm very sorry about that. I think you'll have to ask on Discourse at this point. Discourse.gnome.org, and ask there. The files and GBFS maintainers will likely answer your question. Sorry about that. Right, so C constructors are C constructors. They are not going to be used by anything else except C. So make sure not to make sure not to deal with weird, like make sure not to do weird stuff like this. Doing stuff like this, no, never, ever do this. You're basically creating a black hole into the API. You're also making it harder to deal with when it comes to not only language bindings, but determining the state of an object when it's first created. So the only thing your C constructor should do is call GObject new. So what happens when you call GObject new? We already did a little bit of an outline of what happens whenever you call GObject new, but mostly related to the class in it and the instance in it. What really happens is a little bit more complex than that. It has a little bit more steps involved, and in some of those cases you can intervene with custom code. In other cases you just have to basically just do things in the way that they are provided to you, and it's not something you can change. You have to react to things and not influence them. But in some other cases you can change stuff. So calling GObject new will do, the first thing we'll do, it will be create the class, so it will create the gtype class for your type, and the gtype class, as we seen Friday, it's going to be calling all the class init functions for your type, walking the ancestry of your type. So the first time it will create a gtype class that is the size of my object class, and then we'll call GObject class in it because this type inherits from GObject. And then since your type is a immediate descendant of GObject, we'll call your own class in it. They will be called in order, so you know that whenever you reach this point, the class in it, you know that every other ancestor has had the chance to initialize the class structure for you for that particular type, so you can rely on that. But the gtype class is of course just one thing, because the any typed instance in GObject is composed by two elements, the type class and the instance class. It's also important to note that the class in it, it's going to be called the first time the type is instantiated, which also means that it's going to be called the first time a derived type of a type as being called. So instead of having a final type, if we had a derivable type, and then we had another type that is called my awesome object that inherits from my object here, and we created an instance of my awesome object instead of creating an instance of my object, then my object class in it will still be called and will be called first. So it doesn't matter for the type class if you're actually instantiating a type of that type. and if you're actually instantiating that type, that specific type. If you're instantiating a type that inherits from that type, it will also be called. But the other thing is that it's called once. So it doesn't get called multiple times. It only gets called once, because every single instance will share the exact same class pointer, the exact same class structure. So once we have a type class, what are we going to do with it? Well, at that point, we are going to do a little bit of a sleight of hand. GObject will not actually instantiate the myObject instance structure. It will instead call a virtual function on its own class. So GObject class has a few virtual functions there defined on its class structure, and one of them is constructor. The constructor virtual function is the function that returns the instance of the object, and this is the place where it can do very nasty things with your object class. But for the sake of simplicity, we are going to just say that whenever we reach here, whenever we reach the fact that we have an initialized type class, what GObject new will do is we'll do something like this. Class ref it will call the constructor virtual function on the class, and the return value of that function, that virtual function, will be the instance that we are going to that GObject new is going to return to the user. So this is something that is internal to not internal, it's specific to GObject. It's not something that other types will do. But every time you inherit from GObject, you are inheriting this behavior, which means you have a point in the construction sequence that you can override to do your own thing. You shouldn't do that. Well, it's not entirely true. You can do it for very specific, very specific things, like you want to implement a singleton pattern. So you want to have GObject new always return the same instance to the caller, which isn't fine. I mean, it's entirely possible to do it. It's not great. Let me tell you that it's definitely not great. It has limits when it comes to ownership transfer, the fact that you basically are not allowed to destroy that instance at any point. So don't do that. It's something you can do, but it's not something you should do. So for all intents and purposes, consider that the default version of class constructor is going to be it's going to be something like this. So create a typed instance for my type object. As I said, GObject is a G-type instance at its core. So the base type for any instances that can be created that can inherit from other types is G-type instance in the GObject type system. And this is the construction phase. The construction phase will then, well, whenever you call G-type create instance, the type system will call your instance init function. This is part of a type system, and if you remember on Friday, whenever we register the type, we provided like 4 different types of information. The first one was the size of the class structure, and then the function pointer for the class initialization. And then we provided the size of the instance and the function pointer for the instance initialization, because that is part of the type system. Type system will automatically call this class init and the instance init functions for you. And the instance init function will behave exactly like the class init function, which is the type system will call the instance init function for every single ancestor of your type in sequence until it will reach your own type. So before calling my object init, it will call GObject init. There is a terrible trick that happens in the instance initialization function for reasons that are mostly they have to deal with information hiding and with the way things are structured when it comes to inheritance in C. So the function pointer that gets the instance pointer that gets passed to the instance init will have the type of the object it's initializing. If you look inside the code for GObject and you find GObject init, and then you print a name like print let's use the macro name. So if you print out the type name of the object currently being initialized, it will return you not the type that you're actually instantiating, but the type that you're actually initializing. It's bonkers, I know. Which is why you cannot like walk backwards into your inheritance chain. This is, I mean, it's documented, but nobody actually takes that into consideration because it's very complicated, and also because the macros hide it from you. If you look at the real definition for the instance initialization function, you will see that it takes 2 pointers. It takes 2 pointers. The first one is the object you're initializing, but and the second one is the type that you're actually the second one is the type that you're actually initializing. But the gdefined type macros will hide it from you, so you will only get one object will only get one argument, and it's the object that you're initializing. Hi, Georges. So it's kind of a trick that the type system is playing on you at this point, but this is mostly necessary because otherwise people could literally do if GDK is widget, do something with a widget. Which is a layering violation the size of, I don't know, Texas. So you are completely shielded from the fact that when GObject init is getting called, you are actually initializing something that is not a GObject but is not that type. So you have to be extremely careful when that happens. But it's also why, for instance, you cannot do like some sort of type discrimination whenever you are initializing a type, because the type will be the type you're initializing, not the final type that you're actually constructing. So this is a little bit of a word to the wise and a warning. If you ever do type check, you're basically on your own. So you might ask, okay, we've seen what the class init does. The class init initializes stuff like properties. We'll see initializes signals, initializes class that initializes state that it's shared across all classes, across all instances of a specific class. What does the instance init function do? What it does is it creates the initial state of the instance, which means it creates an instance that is in a neutral state, or as neutral as possible. Because my object init, well, the instance init function gets called before any other API like properties that get passed to the constructor. So by the time you do this, for instance, the instance init function will not know that you also set a property at construction time. So the overall idea for the instance init function is to be the neutral state of everything. The values of every single field must be initialized to their default value, unless that default value is 0 or null or false or whatever, because that is implicitly, well, it's an explicit guarantee of GObject, but basically the object data is always going to be 0 filled whenever you reach my object init. So you have to initialize stuff there, and you have to initialize stuff there that is as neutral as possible. If nothing gets passed to the constructor, so no properties are passed to the constructor, that's fine. The end result of my object init should be an object that is usable and does not depend on any property being set or unset. And we'll see what this also implies when we reach the other side of the lifetime of an object, which means when we are destructing an object. But basically, at the end of my object init, you should have an object that is as neutral as it possibly can be. It has to be in a valid state. It has to be possible to call API, like internal API on it, or API that is from its ancestor classes. So it has to be usable out of the box, but not require any further state to be set in order to be accessible. So let's give an example here, for instance. This is going to be like a person style object. So let's add a name and an age. That's it. And then we will have we're going to have two properties. Here, and then we are gonna have object jobs. Let's indent a little bit to avoid runaway lines. Okay, 0 to okay. Actually, let's do something like this. And then we do GObject class property. And then object class install and there you go. We're gonna need the set property and get property, but those are the same as last time, so we're gonna give them for granted right now. So we have two properties here. The first one is a string type. It's readable and writable, and it has static string, so the name here and age are not going to be copied. They're going to be taken for as pointers. The name is a construct property, sorry, constructor. It's a constructor property, which means that we can pass it to myObject_new, to GObject_new, and it has explicit notify. So the setter will have to call GObject_notify by itself. The age property is an assigned integer property that goes from 0 to max uint. It's readable only as static strings, and since it's readable, well, it doesn't matter if it's explicit notify, because it will always be notified and cannot be written down by GObject_new or GObject_set. We override the set property and get property, and we install the properties, and that's it. So we pass a name here, and this is how we construct the object. So we construct the like kind of a person type. It's kind of a trivial example, but it's useful because it's something that it's understandable without going too much into the woods. So by the time we reach myObject_init here, because we call myObject_new, which called GObject_new, which instantiated the class, which constructed the instance, the name is unset. So we don't have anything here, and which means that the assert self name equals null and the assert self age equals 0. These two assertion here will be guaranteed by GObject. Now you will think, okay, what if I call GObject_new without a name? So I create a new instance, but that instance doesn't have any name whatsoever. You will think, okay, let's add a default here, and let's give my name. You will think, okay, this function here, this value here will be set, at which point this name will be, let's do it like this. So this will be valid, right? Wrong, because myObject_init is called before any property is passed and is set. So this will still be valid. So myObject_init is called before any other property is set, even if the property is marked as constructor here. So actually we can remove the constructor here because we have to explain what happens after that. So let's take it like this, and it's going to be fine. So when are the properties actually set? They are set after init has been called and before myObject_new returns. So if you have all these properties here, they will be set using myObject_setProperty. So myObject_setProperty will be called for any property defined here in the constructor that has been set at construction time. Just like if you actually did object and then the object set this is exactly the same thing, does exactly the same thing. You also have two other options though. For instance, you can say that this property can only be set at construction time. So this property can only be set when you call GObject new, which means you add this flag here. And if you try and do this, the GObject set call will fail because you cannot set the name property after construction time. And remember never to do this with a name. Names are not fixed. GObject will also do an interesting trick for you. So you specify that this property is construct or constructor only, which means that it will be passed to the constructor here and can only be set, for instance, at construction time. What happens if you don't set it? Well, two things will happen here. One is GObject will, if you don't set a property at construction time, GObject will take the default value from the gparam spec and create a property value for you at construction time, which means that if you specify that a property has been going to be used at construction time, GObject will set it at construction time if you haven't set it yourself. Otherwise, the default value that you see here inside the gparam spec string or the gparam spec uint, so if I decided that everyone should have 42 as the default age at construction time, this value here will not be used anywhere else. It will only be used if you specify that this property is set at construction time. And if the property is set at construction time and you're not specifying it, so you don't pass it to the constructor, then GObject will set it for you, will create the value for you with the default value and then call myObjectSetProperty with it. So the very important thing to note is that if you have a value, a numerical value, or any other value in a property that is the default and it's not a constructor property, or even if it is a constructor property, but if it's not a constructor property especially, you have to set it inside the instance init function, because otherwise this will be always 0. So here you want to have self age 42 if the default value is set also here. So remember that every time you set a default value here inside a gparam spec definition that is not 0 or null, you have to specify it inside the instance init. Otherwise, GObject will not do it for you. It only happens for construct properties. And it only happens for construct properties that you haven't passed to the constructor. So there is another step in this process that you don't have to deal with, but it's useful if you're doing something that is that happens after initialization and after the constructor properties have been set. So let's assume, for instance, that you really want the name to be not just a constructor property, but also you want it to always be set by the time myObjectNew returns, even if you pass null to the C API. And if you want to do that, you have the option to do that by overriding another virtual function inside GObject, which is called constructor. The constructor virtual function that we can see here is a pretty simple virtual function. So you have the constructed virtual function implementation here. You have to chain up to the parent implementation. MyObject parent class is defined by gdefine type and gdefine final type, and it's a pointer to the class structure of the parent type of your own type. This allows you to chain up. In Python, it will be super constructed. Also, JavaScript has the same concept here, and the Rust bindings have their own parent constructed function that is auto-generated for you. So the concept is kind of similar. Well, the concept is pretty much the same. It allows you to say, okay, I'm doing something myself, and then I want to ensure that anything that my parent type is also doing gets executed at that same time. So when is the constructed virtual function actually invoked? It is invoked after the instance init function, and after the constructor properties are set, but before the non-constructor properties are set, which is sadly a problem. But yeah, this is one of the things that we cannot change. We noticed this long after we merged this new functionality. It was a change that happened for no apparent reason. But now we cannot change it anymore because we break existing code, which is awesome. So let's assume that you have a constructor property here, but also you have a non-constructor property here. So let's say name is a constructor property and address is a non-constructor property. So you can set it whenever you want, and it's also not going to be part of the construction sequence. The constructed virtual function will be called after name is set, but before address is set. Again, it's a pain. It would be a lot easier, a lot simpler if the constructed virtual function were to be called after all properties passed to the constructor had been set. Sadly, that's not the case. It's still useful though, because at this point you can do something like this. Since name is a constructor property, we expect it to be part of the constructor. If doesn't get set at construction time, the default value is null. So we override the constructor virtual function and we check if the name is set to something that is not null. And if it is null, it means that nothing was passed to the constructor for this property. And we can error out and bail out completely from our process and say, the name is required. Or something like this even. This is a runtime check that basically guarantees consistency whenever you are imposing some functionality on top of. Sadly, we don't have any way to specify that the name property is mandatory at construction time using like introspection annotations or something like that. We don't have that yet. At some point we will. There are some proposals for that. But basically, being able to say that this property is going to be required at construction time, it means that language bindings, for instance, can bail out long before the object is constructed, and we avoid like an assertion failure that cannot be caught by anything. But for the time being, especially if you're writing in C and you have constructor properties that you want to ensure are being set, even when you're calling GObject new instead of calling the C API, then you should override the constructed virtual function, and you should check that the internal state of the object post-construction is the expected one. Again, you have to be careful about checking the constructor properties and not all the properties. So if you depend on a property to be set after the constructor, if you expect a property to be set using the constructed virtual function, then you have to ensure that that property is marked as a constructor property. Otherwise, well, tough luck. You're not going to be able to do it. I mean, yeah, there is one way to do it, and it's so jank that I'm not going to spend any like moment on this. But basically, it's overriding the constructor virtual function. So you create your own instance of GObject. You're creating your own instance of your object, and then you check before returning it that the object is in a consistent state. Because of course, the constructor virtual function gets called to construct the instance, which means that you have access to all the properties that have been passed to the constructor. Again, don't do that. It's a lot easier, a lot less error prone, and a lot cleaner as well to just mark a property as, okay, I want this property to be set post construction time. I kind of rely on it, which means then you just override the constructed virtual function and you check the state post construction, and you're gonna be fine there. And at some point we will have an annotation that will encode this behavior for other languages that are not C. And at the end of this process, you should have an object instance that is hopefully initialized the way you like and the way you want it to, and it's going to be fine for you to use. All the properties will be set. Everything that is constructor or constructor only will be set either by you or by GObject, and all the defaults will be set as well. So this is the step one of your object lifetime, the beginnings of that particular cycle. The lifetime of an object is determined by its reference count. So GObject is a reference counted type, which means that every time you have to do something with it, and you want to keep that object around for whatever, however amount of time you want to, you acquire a reference to it, and then when you're done with it, you can release that reference. So if you do something like I don't know, yeah, something like self owner, well, file time passes, then you do the object unref, well, gclear object actually. So you acquire reference on the child object, for instance. Some time passes, you don't care about it anymore. You call gclear object, which calls GObject unref, and then sets self child to null. So basically, GObject unref, and that's it. Reference counting is garbage collection. It's the dual operation of a mark and sweep garbage collector, which means that stuff, well, any instance is alive for as long as something acquires a strong reference on it. And once that strong reference is released, we check if the instance still has a reference to it, or if it was the last reference. And we always start with a reference count of 1 whenever you call GObject new. So GObject new will return to you an object, an instance of an object with a reference count of 1. Because a constructor transfers the ownership of the instance it just created to you. There is nothing else that owns a reference to it because you just created it. This is, strictly speaking, not entirely the truth, but it's complicated, so I'm going to leave it off to the side. The typical case is you call GObject new, you get a new instance with a reference count of 1, which means you own the reference, you own the instance yourself now. And it's up to you to release that reference when you're done with it. So let's skip ahead and see what happens when, after calling GObject new, you call GObject unref on an instance. So if it's the last reference on the object, so it nothing now owns a reference on it, which means that the object is ready to be collected. What happens then is that GObject will do a two-phase collection, garbage collection. And those two phases are GObject dispose and GObject finalize. Why two virtual functions for something that is theoretically a single operation? The reason why is reference counting. So reference counting, as I said, is the dual of a mark and sweep garbage collector, which means that you have the ability to say, the bookkeeping of the reference count of the bookkeeping of the references is owned by the instances themselves. There is no accounting object that lives outside of your business logic that keeps track of what is alive and what can be collected, what can be deallocated. So you can have cases where instance A of an object owns a reference on instance B of another object, and B, through no fault of his own, owns a reference on A. This is a reference cycle. A owns B and B owns A. So say, by way of an example, child equals GObject ref child, and then you do my child set parent and inside my child set parent you do child parent equals GObject ref. Now, at some point, we will do something like we unref the parent. We drop the reference count on the parent because we decided to remove an entire bunch of UI elements from our application. We are dropping a reference on the parent, but since the child of the parent also owns a reference on the parent, what happens? Happens that we leak the parent because the parent has an additional reference instead of having just one. So we end up with a memory leak. In order to avoid that particular scenario, you have, of course, the ability to say, well, the parent should probably not, the child should not acquire a reference on the parent. And of course, you'd be correct. But you're also setting up yourself for weird cases where the child, for instance, is operating on a pointer that doesn't exist anymore. So you have a dangling reference. But in general, it's not something you can mandate at the API level because the API has no idea this reference is happening. C doesn't have strong references or weak references. It only has pointers, and you're copying pointers around. So you cannot really avoid this. And in order to give you a way to cut the reference cycles, you have the option to have two separate phases in the destruction of your instances. So for instance, instead of, sorry, not for instance, but so when you release your reference on the parent, and that is the last reference, for instance, we enter the dispose phase. So we enter the dispose virtual function. And the last thing you do in a dispose implementation is you chain up to the parent implementation. Always remember to do this as the last bit, because if you don't do it, you are interrupting the chain, which means that the object doesn't actually get disposed, the memory doesn't get actually freed, and you have a live object somewhere in memory and nobody knows what happened to it. And inside the dispose function implementation, you do one thing and one thing only, which is you release any reference on anything that you acquired during the lifetime of your object. So you take, if you at any point in time your instance got acquired another object as a reference to it, for instance, your my object here, instead of having just char name here, had an other state object here, and at some point you had a function that is what are you doing? And you did something like state equals GObject ref. Then inside your dispose function, you call the clear object. Which means you release the reference on the state if any exists, and then you nullify the field. The nullification of the field is another important thing, and it's something that you should always remember to do, because dispose can be called multiple times. Again, reference cycles. If at the end of the dispose function, we called some other API that temporarily added a reference to my object, GObject will call dispose again. Or if another case, we call some API that removes a reference from my object, it will re-enter this particular function here. And at that point, you really want to make sure that you're not trying to free stuff twice. So the rule number 2 of a dispose implementation, rule number 1 is always chain up to the parent implementation at the end. The rule number 2 is every time you release some memory, you release some reference inside the dispose function, or you release some resource in any way, shape, or form, then nullify the field so that you don't accidentally do that twice or n times, and you end up causing a double free or additional references being lost. So when the destruction sequence reaches dispose, we stay there until we've released everything, and if at the end of the dispose function, when we finish chaining up the object, the instance here, reached a reference count of 0, so nothing else is holding a reference on this object, then the last step, and last and final step, is finalize. Just like dispose, rule number 1, at the end of finalize, you chain up to the parent implementation so that the memory of the object can be released completely. And finalize can only be called once, so you don't have to do null checks or anything else unless, of course, you're freeing some memory and the free function is not null safe. But there is no risk of reentrancy. There is no risk of temporary vivification of an instance. So there is no chance that this finalize will be called multiple times. And at the end of finalize, you do things like freeing memory that you allocated at instance time inside your instance or constructor, in this case, functions. So here is where the memory that you allocated at the beginning of the life of this instance gets freed. So this is the difference between a dispose and a finalize implementation. The other important thing about dispose is that at the end of the dispose function, your object should be in a neutral state. The same kind of neutral state as the object had when it was initialized, minus no, let's be more absolute. Basically, the object should be at in the same state as it was when my object init was called. Stuff should be nullified. References should be lost. If you acquired a reference on an object, then during the lifetime of the object itself, then this is the time to release it. When you reach finalize, it's where everything must go. So you go, you set the object state to something that was before my object init, which means everything that you created at init time gets released there. So by the time you reach the end of your finalize function, the object that is there is empty, doesn't do anything. And at that point, GObject will be able to take the memory that it allocated to for the object itself and basically release it to the system. So yeah, this is the life and death of an object in the GObject type system. You create it, initialize it to its neutral state. Properties are applied, constructor first, and then regular properties. In between the constructor and the regular properties, the constructed virtual function gets invoked. And then you're free to do whatever you want to with the object itself. You acquire a reference whenever you want to keep an object around, and you release a reference whenever you are done with it. And when the last reference is dropped, then you get into the dispose virtual function, where you take the object and you put it in neutral, which means that it doesn't do any all the references that it acquired during its lifetime. All the reference to other objects, to other data that it has acquired over time get released, and then you get into the finalized phase. The finalized phase is you release everything you acquired at instance init time. And after that, the object gets collected and it doesn't exist anymore. And yeah, everything that has a virtual function inside this chain, inside of a sequence of these events, then has to be chained up. So you chain up to the constructed, you chain up to dispose, and you chain up to finalize. Instance init and class init are part of the type system, so you don't have to chain up because the type system will do that for you for free. And set property and get property do not have to chain up because the properties are set and retrieved using the actual class that defined them. So you don't have to chain up in set property and get property, because they will never be, your set property and get property will never be called for properties that are defined by parent types, by any ancestor type of your own. So you don't have to worry about that. Which is some sort of inconsistency, yes, but you know, again, could be better, but we kind of make it happen now without breaking everything. So oh, right, it's an hour 46 minutes, so I think we are going to take a little bit of a break, because after this we get signals, and signals are fun. They are, yeah, lots of fun. Flashbacks. But yeah, it's a good place to take stock of what we've done up until now. Mostly because the lifetime of an object is not such a complicated topic that it requires like complete attention forever. Some of this stuff is immediately graspable by looking at the not even the documentation, the basic API. You can understand most of this to the point of using it without having to discern the underlying implementation details, of course. But some of this stuff has, I'm not going to say weird behaviors, but the existence of, for instance, the constructed virtual function has a caveat that is as big as a house. But for the dispose and finalize split are actually complicated, and they are confusing. People are actually having, like, people ask questions about why on earth there are two virtual functions there. So I'm going to take a quick break here, and then we're going to go into signals. It's not going to take like another hour and a half, but signals have some little caveat that here and there that I think it's important to note, especially when it comes to the more esoteric bits of their implementation. So I strongly recommend you stick around if you're interested in signals and their emission and the esoterica of calling a bunch of function pointers in C. So see you in a few minutes, and then we'll go back to the wonderful world of GObject. We're back. At least I hope so, because the stream here seems to have died. Oh, oh man. Okay. Uh-huh. I don't know. Is it live? Yeah, it seems so. Yeah, as I said, my network connection is a little bit wonky, so I have no idea if stuff dies or is still there. Oh, thanks, Caro. Okay. Not Firefox. What are you doing here? For the topic of signals, it's going to be fun because I always forget a bunch of stuff there. You would think that after nearly 20 years, I would remember everything by heart, and it wouldn't be farther from the truth. Okay. So hopefully people are, well, I'm not losing too many people at this point in this. It's not a complicated topic, but it's a lot. It's a lot to take in. Even if you know this stuff, it takes a while before you get into the um, the required mindset. It's not a language thing, because I mean, you can spend some time learning a language, and that language can be as complex as you want it to be. But the overall idea is that the once you learn the language, the concepts inside it all flow from the particular language design. We are talking about a library here. We are talking about a library that was created in response to very specific problems and in response to very specific design decisions and to very specific constraints. And most of them are constraints that existed nearly 25 years ago. And anything that happened after that is the result of a bunch of different people trying to fix some of those design issues and relax some of those constraints in view of other constraints that popped up in the intervening 25 years. For instance, the type system in G-type has a bunch of limits on the size of instance structures and other basic data types, and those limits made complete sense when computers had less than 1 gigabyte of RAM and had very slow network connections and had very slow I/O on mass storage. These days, also everything was 32 bits. So these days, pointers are big, like 64 bits, and you have access to multiple gigabytes of RAM, even on the oldest and simplest device that you can own. And some of those limits do not make sense anymore. So we are trying to fix those, but in doing so, we also have to take care of things like ABI compatibility. You cannot just change the data type of a random data structure, because if you do so, you break the ABI compatibility, and then suddenly stuff that was working perfectly fine ceases to work. And now you have all the application developers and the distribution developers like hunting you down with torches and pitchforks, and you're screwed. So you have to be extremely careful about what you do, and you have to be extremely careful about undoing some of the design choices that were made ages ago. So hopefully some stuff can be changed and will be changed in the future. But yeah, it's a long process. Right, so let's go back to desktop here, and let's see. Yeah, let's talk about signals. So signals are kind of an overloaded term, especially on Unix like POSIX like operating systems. So they have nothing to do with Unix signals. GObject signals are not at all like that. They don't have the same restrictions, they don't have the same semantics. They are not at all that. And there's also the problem that in a lot of cases, especially people that are more familiar with GTK than they are with GObject, they look at the GTK3 API and see a lot of events signals, and they think, oh, signals are events, so I can use these two terms interchangeably. And no, that's not it. That's not it at all as well. So at the very basic level, a signal in GObject is merely a way to group a bunch of functions and give that group of functions a name. And that's it. And instead of calling those functions individually, you call the name, and the name is associated to the list of functions that are attached to that name, which means that they will be all called in sequence, synchronously, in the same thread, until all of them finish, or there is some sort of condition that bails you out in the middle of the cycle. It's just a fancy way of dispatching functions. Really, there is nothing there. It's useful to have those though, because then you can have a way to attach custom code to that particular name and then invoke it, even if that code does not exist within the library that is defining the symbol. And this is how GTK is implemented, this is how GStream is implemented, this is how anything that is based on GObject is actually implemented. The idea of signals is how we do event-driven development in GTK or in any other toolkit that is based on GObject. It's how we do notification of property changes. It's how we do state notification for anything that is more complex than just a single property. So they are a fundamental concept of the GObject type system. And they are not even bound to GObject at all. You can, strictly speaking, create signals for anything that has a typed instance. So anything that is that inherits from G-type instance is, technically speaking, perfectly capable of having signals. But of course, just like you wouldn't add a property to a class after the class instantiation, you would also not add signals to random types in the type system just because you can. Additionally, signals are kind of one of the most complicated things to optimize. We've been going over the code base for 2 decades now, and they are the most complex piece of the type system when it comes to avoiding lots of copies or avoiding lots of trampolines, and it's not great. To the point that the typical recommendation is, if you have a critical section, like a performance critical section, don't ever put a signal into it. If you put a signal into it, it means that it's something that can delay your business logic by an unknown amount of time. So it has to be something that is not critical at all. If you have a critical section, then either don't allow user code to be executed there, or if you explicitly need to, we recommend using a plain C function pointer and not go through signal emission and stuff like that. And why is it slow? It's slow because we are literally doing dispatch of values and using a generic interface, which is something that C doesn't really allow. The overall idea is that you can define a signal at runtime to have any number of arguments and have a return value or not. And those values are not going to be defined precisely as the C ABI would. They are function pointers, and function pointers in C, at the very least the strict subset of C that we rely on, we as in GObject, function pointers can be called for any type of function. So the overall idea is that you have to take any argument that you pass to the signal, and then you have to box it into something that can describe its contents. And then we unpack it when it's needed, and we need to call the C API. Can be inlined by an optimizing compiler? No, it cannot be inlined at all. Must not be inlined, otherwise everything breaks and falls apart. It also removes any sort of type safety that C, like any illusion of type safety that C even provides. So it's gone. It's all generic function pointer code and generic container types, and it has to happen that way also because the data that you're passing around is passed to something that is not C at all. So if you have a Python like callback, then you have to pack everything that the C callback will pass to Python, and then vice versa. And that happens using like generic value containers. And we already have generic value containers in GObject. We use them for properties. They're called gValue. So at the end of the day, a gsignal, well, sorry, not a gsignal, but a signal in GObject is we take a function in C and then we generate another function that takes a boxed version of every single value that every single argument that the C function takes. And then we unpack it when it's needed, and then we pack the return value if that is present, otherwise we leave it alone. And then we go to the next function, and the next function, and the next function, and so on and so forth, until we exhausted the list of functions that have been associated to the signal name. So, how do we define a signal? Well, first of all, exactly like we define properties using enumeration here, we also define signals using an enumeration type. Let's say related. And then Marshall matters. Circularies. Yes, it's a law of marshalling. Marshalling and demarshalling. So we do this and we do this, and then we create a new signal. This signal new. So let's go here. So we have a reference. So the first thing we do is the signal name. We call it validated. Then we need the type that this signal is associated with. In this case is my type object. And then we want the signal flags. In this case, we call it gsignal run last. This is the flag that we are interested in. And we want a class offset. So yeah, I'm going to explain this at the end. So for the time being, it's going to be validated. Then we don't care about any accumulator data, and the C marshaller is also going to be null. Doesn't have any return value, and it doesn't have any argument. So as you can see, we are not actually adding the signal anywhere, which is weird, right? We are installing properties on GObject, but we are not installing the signal on the object itself. We're just storing an identifier that gsignal new returns. This is because signals are not stored inside objects, unlike properties. They are not tied to the object. They are tied to the type. And as I said, anything that has there is an instance type can have signals. This is another difference between object and properties and signals. Properties are concept of GObject. If you create a new derived type of gtype instance with a completely separate type hierarchy, then you have to re-implement properties as well. Whereas signals, they are concept at the they are fundamental concept of the type system. So whenever you create a new signal, you have to specify the type to which this signal belongs to. Which also means that any other derived type will have the same signal. Then we have the flags. The flags are various. In this case, I opted for gsignal run last because this is a very simple signal. The two main flags that you will ever use are run first and run last. The main difference between the two is when the class closure will be called. And the class closure is the function that will be called if nothing else has blocked the signal emission during this phase. So you have two options. Whenever you connect to a signal, you call gsignal connect, object, validated, gcallback, on validated. So you connected to this, to the signal, to the validated signal this way, right? If you have never seen this particular kind of API, then this is how you connect to an object. But if you've seen it, this should not be you should not come at a complete completely out of the blue. This means that every time the validated signal is emitted, I want the onValidated function to be called. That's it. And this one is treated like none. So let's assume that you have multiple calls, multiple callbacks attached to the same signal, right? So validated 1, validated 2, 3, and 4. The run last and run first flags, so run last and run first, decide when the class closure, so this function here that is at the given offset inside the class structure, but also can be you can use another where is it? Yeah, you can override it using a function, an actual function here, using gsignal override class closure, class handler. So this one could as easily be 0 here. It's fine. And then you do gsignal override class closure for object signals validated, then my type object here, and then now let's use class handler because I don't want to create a closure object. And this is going to be my object real validated. So class validated equals my object real validated here, and that's it. So you have these two options. One is you define, so option 1 is this, and this is option 2. So if you have a virtual function in your class and you want to associate that virtual function to your to the signal emission, then you do this. Because then gsignal will then take the function pointer at the offset of the validated field inside the class structure, and which is in this case a function pointer here, and will invoke it. Otherwise, if you don't have a virtual function inside your data structure. Because, for instance, this is a final type and the class structure doesn't have any fields, you can still define a class handler by using this particular mechanism, using an actual function, using gsignal override class handler. But basically what this does is, if we have a bunch of callbacks connected using the gsignal connect API, I want to be able to call a function inside my own implementation that is associated with the class that I'm actually defining. So run first will say, okay, I'm going to call my object real validated first. Then I'm going to call every single callback defined by every single callback connected using gsignal connect. Whereas if I used gsignal run last, the class closure will be called after all the callbacks attached using gsignal connect have been executed. So this is the main difference between the two flags. Do I call it first or do I call it last? That's it. There's nothing else to it. The reason why you would want this to be called first is because you want to have a default behavior and you have some state that you have to set up and you have to deal with, and you have to ensure that it's always there. Of course, the downside is that the all the callbacks here cannot override the behavior that you set in your class closure. Run last, on the other hand, allows you to define some internal state that will be set at the end of the signal emission, but it also means that any signal emission here could, in theory, just bail out and stop the signal emission at some point, which means that default code doesn't get executed. So there are pros and cons for any of these two options. Hi, Pervoj. And the callbacks are called in the order they defined? Yes, they are. The order is the same order in which they have been connected. So it's always going to be, in case of run first, it's going to be the class closure, all the callbacks connected in the same order they have been connected, and then end of the signal emission. Run last is going to be all the callbacks in order, and then class closure. So there are other considerations for signals that are interesting. In this case, I decided to pass null and null for the accumulator. If I don't switch to something that doesn't make any sense, to the accumulator and the accumulator data. The accumulator is a function that gets invoked at the end of every single marshaller, every single callback. So where are you? Here. So one of the things that you might have seen in GTK, especially GTK 3, is that some signals have a return value, and that return value decides whether or not the signal emission should stop or continue to the next callback, the next handler of the signal. That functionality is implemented using a signal accumulator. The signal accumulator, all it does is it receives the return value of the last handler that was executed, and then it will also give you the ability to set the return value in case you have some additional rule that is under your purview. And then you can decide to whether or not to interrupt the signal chain by returning, in this case, returning false from the accumulator itself. This allows you to implement stuff like the event handling, the event handler, behavior of the signal handler return GDK event continue. It's the equivalent of returning true. If the signal handler return GDK event, well, no, it was GDK event propagate and GDK event stop. Propagate will continue, so it's the equivalent of returning true, and GDK event stop is the equivalent of returning false. So this function here will be called every time after, well, be called after your handler has completed its own invocation. So it happens every single time. This way you can deal with things like let's prevent the signal chain to continue, or there's another case that is also useful that happens in GTK is the creation of a GL context for the GL area widget. So the GL area widget has a signal that is called create GL context, which means that if you connect to the signal and you have a callback and you decide to return, you create a GDK GL context and you return it from that signal handler, then the GDK GL area widget will take that GL context and use it from now on for any single drawing operation. The overall idea is that the first time a handler returns a GL context, you don't have to create any more GL contexts. So the first handler that returns a GL context wins. And this is implemented, again, using a signal accumulator. But in this case, we don't care. So we return null. The one of the last arguments is the marshaller here. The marshaller is where all the logic for the trampoline from the signal emission chain into the actual C function happens. Well, not just C functions, but any other function, like in different languages. When that happens, it's the function that gets all the G values that wrap the actual values that you're passing to the signal emission are converted into real C values, and the function, the C function that it's associated with it, gets invoked. And up until when was that? 2009, I think. When was the GD bus merged? I think it was 2009, 2010 at the most. So, and more than 10 years ago. So before that particular event, so before we landed GD bus inside glib, marshallers had to be written. So you had to write the marshaller code yourself, or more often than not, it was a case of generating it using a code generator called glib gen marshal. The overall idea is that you specify the number of arguments, well, the arguments and the return value, and then this little tool would generate a bunch of C for you. And then you took that C code generated inside a separate file, and then you compiled it with your own project, and you'll be set. Which is fine. It's perfectly acceptable. The other option is, and again, this happened after GBus was merged into GIO. Again, 2009, 2010. There is another option, which is we used libffi, the foreign function interface library, to transform the values that are described by g-value inside our signal emission and transform them into native C types. And we do that automatically. So we don't have to unpack values manually, and we don't have to deal with weird rules for ownership or anything else like that. We basically have a mini language binding ourselves into glib that transforms values into C values and vice versa, using the same kind of interface that other languages like, I don't know, Rust or Go or I don't know, Python even use to bridge their own API into the C API. And that is why you use null here. If you don't pass any marshaller there, you're telling glib, hey, use the default one, use libffi and do your thing, and we're gonna be fine. The downside is that it's actually slower because the transformation between gvalue and libffi is not like free. So it's a perfectly acceptable performance loss when you're dealing with IPC like GDBus. But it's not, it can be a bit too much for any other kind of signal emission. But as I said earlier, if you're using signal emission inside a critical performance path, you're just asking for trouble. Don't do that. It's pointless to actually optimize that. On the other hand, if you are already committing to that particular path of invoking user code into performance critical paths that you cannot control, then you have the option to skip most of the value transformation from g-value to C values and vice versa by using the VA list marshaller, which will literally take a bunch of g-values and then we'll put them into our VA list, which typically just shoves them on the stack. So that is actually faster. It's not as fast as it could possibly be because we realized that doing that would actually break a bunch of code, a bunch of the guarantees on the code that we have documented as such, so we cannot change them. But it's still faster than unpacking all the g-values and repacking them and so on and so forth. So that's another option that you have. So in order of speed, let's just say, from the lowest to the highest, you have the libffi based generic marshaller that you use by setting null here. The other option is to use a real marshaller, a real function, and in that case you probably want to generate it using glib gen marshal, which is again an automated tool that will generate code for you. And the fastest option is to use the VA list marshaller, which requires you to actually call another function there. Where are you? Yeah, here. Instead of, well, not instead, you also add the ability to set this. So you can do this. Oh, sorry. Signal set VA marshaller. So this case would be something like my object void set VA marshaller object signals validated my object void v sorry, my type object. And my object void is a function that is generated by using glib genmarshal. So you specify a function name. Sorry, you have an ancillary file called usually like your project dash marshal dot list, and you specify them as something like void, meaning this function returns nothing and only has the instance parameter, so it has no additional arguments. And then you call glib genmarshal with the name of the file. And if you specify also VA marshallers, if I remember correctly, it will also generate the VA list version of the same marshaller, which is then you can use here as the VA marshaller for your signal. Yeah. So once you define the signal here, you created the signal, you specify the type of marshaller you wanted to use, and you want to specify the class handler for the signal that gets called at the end, in this case, of the signal emission. What's left to do is emitting the signal. So you typically will have a function like this. It could be static void because you don't want other people to emit the signal, or it can be public function, a public API. And then you will have this gsignal emit. Sorry, validate to 0. And that's it. This function will emit the signal, which means it will call all the callbacks that have been attached to the signal, and then will call the class handler for the signal. You pass it the instance that emitted the signal, and you pass the signal identifier here. And then you, if the signal is like this, so a very plain simple signal, then you pass 0 here. The arguments are all set at the end. here. And so is the return value. So if this signal here had arguments, this one would be like Boolean as a single argument here. This. Then you would pass self-validated like this. And the same thing happens when the return value is not none. So it's an actual return value. You will get the return value at the end of the chain. And again, this is usually a private function because you don't want people to emit signals on your own objects, unless it's an abstract type and you are expecting people to actually derive the type and then emit signal in for like any reason. So you're basically deconstructing the basic type, and you're providing the functionality for implementing other types on top. There is another case though in which you want to have people emitting signals on instances themselves. So being able to call gSignalEmit on an instance, and you signal, no pun intended, that ability by using another flag, which is gSignal action. An action signal is not a signal that you typically connect to. It's typically a signal where you want other people to emit, and then you handle it yourself into the class closure. GTK has a bunch of these signals, the activate signals. The reason why they exist is mostly to allow you to write like key shortcuts. So you basically allow people to emit the signal, and then the class itself will handle that signal emission for key shortcuts and key bindings. They are legacy at this point. We have mostly replaced them all with actions these days because they are better defined and they have better semantics when it comes to overrides and propagation. But it's an option. Once again, you can see a bunch of decisions made by the GObject developers that benefit the GTK developers, but they are kind of weird if you look them through the lens of a generic type system. I mean, action signals make sense when you are implementing a toolkit that has key bindings and you want to be able to override key bindings through things like configuration files or things like that, and you want to have themable key bindings. They don't make any sense whatsoever. In general, they don't make any sense whatsoever. In this particular case, this functionality exists because of GTK. And GTK doesn't even use it anymore. Yeah, the rest of the gSignal API is mostly there to allow you to do two things. The first one is I'm inside a callback and I decided that the signal emission should stop, or I'm inside some code and I want to change some state that will inevitably cause a signal emission. So I want to prevent any signal from being emitted in this particular critical section of me poking around at the state of an object. A case of the former is whenever you want to deal with things like text validation in a GTK editable widget. So you're doing text validation and you want to prevent the default handler, which takes the text that you just inserted inside the widget and commits it to the actual widget so it's visible. And if you're doing validation there, you basically stop the signal emission if the validation fails. A case of the latter, which is the marking critical section, is again inside GTK, and it's the toggle button. Setting the value of setting the active state on a toggle button will emit the toggled signal, and inside the toggle signal you might have some custom code that basically just performs some action. And if you're modifying the state in response to some other condition, you don't want to basically just change the state, cause the toggle signal to be emitted, which will change the state again and might end up either in a infinite like recursion, or it will just perform some additional work that should not be performed. So you mark that particular section, critical section, as please do not ever emit the signal between these 2 points. And in order to do that, you do things like a G-signal handler block and unblock. So you basically say, okay, I connected to the what's it called? I connected to the toggle signal. Whenever I connect a handler to a signal, I get back an identifier, and I don't want the signal, the handler attached to this identifier to be invoked whenever I change something, and then I block and unblock in that to mark the critical section. For instance, this like south toggle ID G signal connect toggle button toggled, go back, toggled, south, then for fuck's sake, then at some point I do something like this: GTK toggle button set active button true. This one will emit the toggled signal here. I don't want that to happen because I'm doing something myself. So I do G-signal handler block toggle button, and then G-signal handler unblock. So the untoggled callback here will not be invoked even if I change the state of the button, and the toggled signal will be emitted because I blocked the handler using the handler ID. And then I can also use the handler ID to disconnect. The signal. handler itself. And then nullify it, like zero it, so I know that it's been disconnected. This is mostly necessary in the case of so whenever you destroy an object, the all the signal handlers that are connected to that object are disconnected and removed. The main problem, of course, happens if you have an object that owns the object you're connecting to. So if you do something like this, and then you connect so what happens when you remove the toggle button here? But for instance, the toggle button is not owned by you, but it's owned by its own parent widget. Whereas the object that has a reference on it will exist at some other point in time. So if this relationship is transient, what happens is the toggle button will continue to exist. The object that temporarily references it also will continue to exist. At some point, the toggle button will be toggled, and you will get a callback that you specified there, even though the toggle button doesn't exist is not referenced anymore. And the only way to do it is that inside your, I don't know, dispose or unset toggle button function, you also disconnect the signal there. So signals are a resource just like any other. If you are temporarily acquiring a reference on an object that you're keeping around, then you definitely want the lifetime of the handler for the signal to be tied to the same object. It's even worse if, for instance, the toggle button exists independently from the object that references it. So instead of creating it there, you have something like this. Something like this. And then you decide to get rid of the object here, but the toggle button still exists. So the object here gets disposed or finalized. Well, let's say disposed. And you do self toggle button, something like this, gclear object self toggle button. And you think, okay, we're fine, right? It's gonna be fine. The toggle button doesn't have a reference anymore. It will exist independently from the object, and the object gets collected as well. So the dispose runs. That was the last reference. The finalized runs, and the object gets collected. Except the signal is still there. The signal does not take a reference or removes a reference or whatever. It's just pointers lying around. The only thing that owns it is the toggle button here. And the toggle button, if the toggle button still lives, at some point you will toggle it, and the callback on toggled, which still exists because it's a function pointer, will be invoked, and the first argument, well, the user data argument is going to be garbage, and you will get garbage there. Segmentation fault, all your pictures will be turned into I don't know, encodings of the GNU libc in reverse. So what happens there? So the only thing you can do is to actually also clear the signal handler there. And you want to do that first. So you can clear it, and then you can clear that. And at that point, the toggled callback here, the on-toggle callback here, will not be invoked anymore, and you will be safe. The other option is to use, if you have an object, instead of having, so this could be a structure here, and this would not be a free, the dispose would be a simple, like, free, let's say, like that. If you have an object instead, and self-toggle, self is an actual object, then you can use gsignalConnect object. Because gsignalConnect object will look at self here, at the object in the user data, and if the object in the user data goes away, then the signal connection also goes away. But that only works for objects. So if you are using this instead of an object in you're using a box type or any other like structured type that is not an object, then you cannot use gsignalConnect object, and you have to clear the handler yourself. So there are a couple of gotchas there with signals, because the lifetime of signals is not necessarily tied to the lifetime of its arguments. It's necessarily tied to the lifetime of the instance parameter, meaning that as soon as the instance parameter for the signal goes away, all the callbacks connected to that particular signal for that particular instance also go away. But they also go away during the dispose sequence. So you might end up with signal emission inside the dispose, inside the dispose sequence, and during the destruction of the object. So you have to be extra careful with that there, because the end result is that you might end up invoking random user code while you're destroying your own object. So that is another reason why your objects during dispose should be placed in a neutral state, so that they don't accidentally cause a crash or invalid memory access or some sort of memory corruption because of unintended side effects of your custom code. Mostly because the library cannot save you here, but also the compiler cannot save you here. The language will not save you here. You're very much on your own. So your code doesn't have to be perfect, of course. No code can ever be perfect. But you have the tools to be careful about what you're doing. And if you don't have the tools in terms of automated tools or your IDE or your macros or whatever have you, you have at the very least the documentation for that. And I sincerely hope you will also have this this deep dive at some point. I do hope to be able to condense all of this into a small video that I can upload and people can follow without having to deal with like 9 hours of me talking about this stuff. But yeah, and again, this is not the I'm not going to say these are the basics of the signals, because I actually covered a little bit more than the basics. But this is pretty much the extent to which signals are used these days in idiomatic code. Older code might do more of this, might end up using the signal, the emission hook, to get notified every time the signal gets emitted, which is very expensive, so don't do that. There are other performance optimizations, like if you have a complex type, like a box type, and you don't want to copy it when you're emitting the signal, then you can tell gsignal, assume that this value is going to be valid for the entirety of the signal emission, and that no signal handler will ever write to it. They will only read to it, because, for instance, it's marked as const. So you don't have to take a copy, or you don't have to take a costly reference, for instance. But in general, those are very esoteric like cases, and most idiomatic code these days does not touch that particular area of the API. If you're implementing a language binding, you will probably have to deal with querying the signals, which means being able to understand, like, do a little bit of there is enough introspection that can be used to understand how the signals are set up. Again, it's only ever useful if you're writing a language binding, and even in that case, you can also use the introspection API, the proper introspection API, to know what kind of signals are available. So you don't actually have to, strictly speaking, use the signal API there. I mean, it's one of the main issues of GObject. You have to use the GObject introspection API directly from libGObject, because it exists there. But also there is a more extensive API for everything else inside libgi repository, which is the GObject introspection library itself. You have to use both if you're writing a language binding. You cannot just use one, because libgi repository has a lot of static information, but gtype is a runtime type system, which means that some stuff has to be discovered at runtime. So you have to use both at the same time. But for instance, for signals, it's not often that you use the introspection API, the introspection capability there. I haven't touched a single thing that I think it's the last thing that we're gonna deal with, because it intersects with the GObject properties, which is the ability to detail a signal, which is another flag that you use here. So if you have a complex signal that gets emitted for a variety of reasons, but also you want to be able to specify a detail for that signal. So by way of example, let's actually use the original detail signal, which is the notify signal in GObject. So I think it's also GRUN first, but it doesn't matter. So let's assume we have the notify signal here. The notify signal is emitted every time a single property changes. That means that every single property in a GObject will emit the notify signal. You might be interested in all the properties of an object. For instance, if you're writing, I don't know, a proxy object that basically proxies the state of one object to another object. But most often you will probably be interested only in a specific subset of the properties you are of an object, and that usually manifests itself like this: G signal connect object notify, I don't know, with. The colon detail here, the colon width, is called a detail, and the detail is an additional string there. So the opposite, the dual of gsignal connect to detail here is this: notify, and instead gsignal emit, sorry, by name, well, gsignal emit actually, and it's gonna be object signals notify, and we've seen before it was 0 when we emitted there the validated signal there, like this. Instead, if you want to notify on a detail, we have to do something like this. So we have to pass a quark here, which is an integer representation of, in this case, a static string. So every time you use with, the quark is going to be exactly the same. It's a numeric identifier. It suffices to say it's a numeric identifier. It's a constant numeric identifier. This means that we are only interested in the notify signal that has a width detail. So we are not interested in all the notify signal emissions. So we are connecting to a specific signal emission for a specific detail here. And on the emission side, we are emitting the notify signal here, but we are emitting it for the width detail. Even if we define gsignal emit here like this, if we're connecting to the notify signal, we are going to get every single notify signal emission, even if it's detailed. The detail only comes into play if we are actually connecting to a detailed signal. And instead of using gsignal, if you don't want to do this because gsignal emit and here and gquark from static string, it's kind of boring, then you can also use gsignal emit by name, and then you do notify with. The gsignal machinery will deal with that by itself. But your implementation will probably use this because, again, it's slightly faster. It doesn't have to parse the signal here, doesn't have to do validation, and so on and so forth. Because this one will give us the signal identifier immediately, and this one will be stored inside memory, so it's already been done. But yeah, this is basically the last remaining bit of signal, of the signal API, the ability to define a detail. Details are mostly useful if you have blanket signal that gets emitted with multiple possible states, for instance, and that state is not going to be a parameter. You want to filter on a specific state right at the point of the connection. So you're only interested in, again, with changes instead of being interested in all property changes. So it's a way to reduce the scope of your own code, of your own handler code. But yeah, that was it for the signals. There is not much else. Again, some esoterica here and there that are that is not really used these days in idiomatic code. And we took a lot less than I expected, actually. Again, this stuff is mostly there. So the idea of this episode of the GObject deep dive is mostly to, well, the idea of the GObject deep dive altogether is to provide you with some reasoning about the idiomatic GObject use of 2022. I also enjoy giving context to some of these best practices and this idiomatic usage, mostly because if you're not familiar with the context, some of the decisions encoded in this API and the design of this feature set is not going to be understandable, or at the very least it's going to be completely arbitrary. And there are reasons why the API behaves the way that it does. Some of them are relevant to these days, some of them are lost in time, but there is a reason why stuff happens the way it happens, and understanding some of the context is probably as important as understanding the API itself. Because if you understand the context, then you have two options. One is, okay, I am going to use the API as it is, and understand the trade-offs that were at the basis of the design decision. But also you can understand if you want to change them and contribute to GObject in the future, because some of the decisions that were made are still valid, or even if they are not as valid as when they were made, they still need to be respected, because we cannot always break. We don't have the luxury of being able to break API whenever we want to, at the very least not for this kind of library. I would love to, trust me, I would love to break the API, but I honestly can't. It would be amazing. Set fire to a lot of this crap. But believe me, a lot of the people that are working on this stuff would love to set fire to it, and not start from scratch, but give a better API to a lot of users, like basically just merging 99% of the introspection API directly inside GObject, in order to be able to reflect on the type system without having to deal with this weird split between GObject introspection and GObject itself. But some stuff might happen in the future if there are enough resources to do that. But a lot of the blockers for some of the changes that we're planning or that we envision are mostly we don't have enough resources to commit to an API break, and we don't have enough resources to commit to dealing with downstream changes of an API break. So this is all that we can do with the resources that we are giving. If you want to make stuff happen, then you can definitely join us, and you can definitely join the GNOME project and start looking at glib and GObject and try to figure out what can be done in this project. As I said, the code base, the only complication that exists is that it's old, and it could be better documented, but it's not completely devoid of documentation or comments. And the history of the Git repository is also very informative, because there is a lot of information over the years about it. So it's possible to reconstruct some of the decisions, or at the very least reverse engineer the process that led to some of the decision. In other cases, it's been there since day one. Nobody actually ever thought about how to deal with this very deeply. So we are just stringing along some of the initial implementation that got unreviewed, that wasn't reviewed properly, because at the time we were using CVS and Bugzilla, and there were like 3 people working on the same project, and they didn't need to do actual code reviews. So this is what happens. In any case, I think this is time for the outro for this episode of the GObject Deep Dive. So if you enjoy the history of the GNOME project and its software development platform, then why not join me while I disassemble the entirety of GObject and GTK to try to understand some of the reasons why they are the way they are, and try to offer some perspective on the decisions made 20 years ago. If you enjoyed doing that, then you can subscribe to my YouTube channel where I upload the VODs, or you can follow me on Twitch, twitch.tv/ebassi. You will get notification as soon as I start streaming, which is usually Monday, Wednesday, and Friday at 4 p.m. London time. If you're still here, thank you very much for following along, and I hope you enjoyed this, or I hope I didn't like burn your brain too much with all this information. And if you already knew a lot of this stuff, I hope I explained some stuff that you didn't understand, or I clarified some stuff that you didn't understand. I don't know. Maybe it works, maybe it doesn't, but it's another source of documentation, and I kind of enjoy having more documentation than having less documentation these days. I hope you have a great rest of your Monday, and as I said at the beginning, I will not be able to stream on Wednesday because I have new ISP technician coming over and basically destroying my internet connection, so I will likely not be able to do another deep dive on Wednesday. I'll try to do it on Friday at this point. There isn't much else left to discuss except interfaces. Interfaces are a fun topic because people get them wrong most of the time, and they also have some interesting caveats around properties, especially overriding stuff. But other than that, I shall see you all on Friday for the likely last episode of the GObject deep dive. If you have any suggestion for other deep dives inside the GNOME platform, please feel free to leave a comment either on Twitch or on YouTube as soon as this VOD goes up. So I appreciate any suggestion, and I will try to answer them as best as I can. Other than that, I shall see you all on Friday. Bye.